Hello, good evening. Welcome to actually the last part of our program, but definitely the most exciting part. Not only because we share the fact that we are both from Slovakia with Michaela, Musilova, and yeah, it's really a great pleasure to welcome you here. I would like to present like a little bit about you to the audience, just in case not everybody had time to read the bios. I'm gonna read it just to make sure I say everything correctly. So, Dr. Michaela Musilova is an award-winning astrobiologist, explorer, keynote speaker, and author. Michaela has been conducting space-related research at institutions around the world, including NASA, ESA, Caltech, University College London, Chiba University in Japan, Canada France Hawaii Telescope, and many others. She was also the commander of over 30 simulated missions to the Moon and Mars, the most missions led on record in collaboration with NASA and many international organizations. Currently, Michaela is the president and founder of the non-profit Extreme Frontiers. She's pioneering a unique global project, Astro 7 Summits. It represents a world first in combining expeditions to the highest mountain on each continent together with scientific research in cooperation with NASA and institutions worldwide, educational activities and filming documentaries. Michaela's work has been recognized through numerous awards, including Forbes Slovakia's Most Promising 30 Under 30, Top 100 Aerospace and Aviation Professionals on LinkedIn in 2021 and 22, and the Emerging Space Leaders Grant. She was even selected to journey to Antarctica with the largest all-female STEM expedition. A great part of Michaela's work is teaching and giving keynote presentations to audiences of all ages around the world. Her outreach work with international media, and her biography, A Woman from Mars, aim to help educate and empower young people worldwide. Furthermore, she is helping others succeed in the space sector as global faculty at the International Space University, ambassador for Space Scavengers, and the head of research of Nidronics. So for me, Michaela is really a great example of a woman scientist leader, and I will not hold on anymore, and the stage is yours. Thank you very much.
Thank you so much. Thank you very much for the very nice introduction. Thank you. It's a pleasure to be here. Hi, everyone, and thank you very much for inviting me and for the organizers for everything they've done to help me be here in the first place, as I'm based in the US, and it's always wonderful to be able to go back to Europe and actually very close to home. As was said, I'm from Slovakia originally, though I've had to spend a lot of time in my life away from my home for various reasons, and that's a little bit what I will talk about today. And that's actually my big childhood dream, to go to Mars one day, or to space at least, to do research. And on that picture, that's me, and not on Mars yet, unfortunately, but working on it. But this is kind of where I'm hoping to go with actually everything I've been doing so far in my life. So where did it all start? It all started when I was a little girl. You can see me in this picture here. I was about 8 years old, wearing a simulated NASA suit, and actually my space dream started even earlier than that. I was a very curious child. I wanted to know more about how everything worked in the world. For example, why volcanoes erupted and all the damage they cause. Later, I found a similar passion for space. I wanted to see if there's some aliens out there, and ideally I wanted to study this. But at the time, astrobiology, so the search for alien life, did not exist as something you could just study. So I just called it space biology, and I was hoping that one day I'll be able to work in this sector. But it was actually around when I was maybe 10 years old, I had the opportunity to meet these two gentlemen on the picture. The one with the Slovakian flag, he is so far our only cosmonaut or astronaut that has gone to space from Slovakia. And the other gentleman on the right, oh, sorry, the microphone being weird. Yep. Yeah, no, that's fine. Here. There we go. Helping? Okay, good. Yeah, I thought I heard something weird. So the gentleman on the right, he was so far the last man to walk on the moon, Gene Cernan, and he had Czech and Slovak origin. He is not with us anymore. And when I was, about 10 years old, my father organized a meeting as a diplomat between these two gentlemen because of their kind of shared origins and space activities. And they're the ones that inspired me in a way to actually dream beyond just searching for aliens myself as an astrobiologist, but actually to go to space and look for aliens there. So that's when I started to dream of actually wanting to become an astronaut and doing the astrobiology there. However, as someone from Slovakia, wanting to go to space is unfortunately an almost impossible dream at the moment, and it definitely was when I was a little girl. And that's because until recently, Slovakians had essentially no possibility of going to space through a space agency or any means like that. For example, to be a NASA astronaut, you have to have American citizenship. And our astronaut, Bella, went to space through a sort of exchange program with Russia because of some debts that were there. And so instead of paying off the debt, they gave us the option of sending someone to space. And a similar option has not come by in the meantime. So I already knew at that age that wanting to follow this dream is going to be very difficult and potentially impossible, but I didn't let it dissuade me. And I always try to find some way to make it happen so that later in life, I'll know that I gave it my best shot. And actually, it's been quite the journey, as I'll tell you in a moment. So I definitely don't regret taking on such a challenge. So for instance, already when I was a teenager, I knew that I would have to go abroad to be able to study something close to space. In Slovakia, there weren't many options to study different types of space studies, definitely not astrobiology. Actually, you couldn't study astrobiology anywhere in the world at the time. And so instead, I decided, okay, I have to create my own path. What is astrobiology? Let's start with that. It's the search for alien life, but it's also about how did life originate on our planet and whether we, as a human species, have a possibility of living beyond Earth. So you can imagine it's a lot of different subjects. It's very complicated, and to do astrobiology properly, you have to be able to study in multiple disciplines. And so that's what I decided to do. I knew that I would have to study geology. That's this picture here in the red, me doing some geology. I knew that I'd have to do some astrophysics, and later I definitely knew I needed to add some biology to the mix. I just wasn't sure exactly how to do it. And so geology is important because we need to study planets like Mars to see whether the surface of Mars could currently hold any life forms, or in the past it was possible for something to live there. Astrophysics, we need that to be able to study planets and moons that are way beyond even our solar system, for example, exoplanets, planets that orbit other stars. And then biology, of course, to understand what are the limits of life on Earth and whether we can find similar or even different life beyond our planet. So from the age of 15, I was like, okay, I need to create this path, not sure how to do it. So let me just start by having multiple jobs. As a teenager, I would work during my school hours, sometimes, definitely every single summer, just to save as much money as possible, because I knew I had to go abroad to be able to get to these interesting subjects. And I also tried to get the best possible grades, so I could get scholarships, and all that really helped. And I was able to get into the UK, to University College London, on scholarships where I studied planetary science, so a combination of geology and astrophysics, as you can see in the pictures. However, there was no option to add biology to my studies. The other problem was that living in London was very expensive, and everything that I had saved up as a teenager and all the scholarships were not enough. And so I had to have more jobs. Actually, I would have like 3 jobs at the same time while studying, also to try and get the best possible grades, to get more scholarships. I was basically applying to every single grant that I could find at the time, and it was still barely making it even for me to cover all those costs. Even charities actually helped me out, and I would send out hundreds of letters asking charities for help, and sometimes I would only get maybe 5 letters back with some kind of response. So it was a tough time, but it was all worth it. Because I went out of my way to get these scholarships, do different types of internships, and work on extracurricular projects, I stood out as a student. And then in my second year of the university, there was a competition in the UK, and they were going to select 2 students to go to the American University Caltech. At the time, it was considered one of the best universities, if not the best, in the subjects that I was interested in. And the scholarship was worth about $50,000, so completely unimaginable money for me at the time. But I told myself, it's worth a shot. Let's give it a try, see what happens. And in the end, fortunately, I was selected as one of 2 people, and the other nice little irony is it was me and a Czech guy that were representing Britain at Caltech through this scholarship. So nice little Czechoslovak collaboration. And that's what opened my doors to finally study biology. So yeah, that's the picture down here, doing some lab work. And the other great thing about Caltech, not only did it open doors for me to be able to do research that I was really interested in, so closer to astrobiology, but Caltech is also has a collaboration with NASA JPL, also in Los Angeles. And when I found out about that, I was like, I have to find a way to work for NASA, and they must do astrobiology research there. That's around the time when I figured out that astrobiology actually does exist, but at the time, maybe less than 100 people were doing it. However, the researcher in charge of astrobiology told me that he loves my enthusiasm, he loves my ideas, but as a foreign student in the US, I'm not allowed to work for NASA. It was a visa rule at the time. But I didn't let myself be dissuaded just there either. And I was like, is there any other way? Maybe I could work for you for free or do some kind of internship or something. And I think he just really liked my perseverance and all the ideas that I shared with him. So eventually we were able to apply for a grant together, and I ended up working for NASA as a visiting researcher. And that's how we kind of bypassed the rules that were unfortunately kind of stopping me in the first place. So what did I do at NASA? I was trying to do astrobiology research, but maybe from a different perspective than I originally planned. So I was actually working on the rover Curiosity, and that's the one in the picture in the middle. At the time they were building it, and that's what you can see in the picture all the way on the right. You can see they're wearing these white outfits. Unfortunately, probably most of us are familiar with those from the pandemic times. And during the pandemic, we were trying to protect each other from spreading the virus. Here, we're actually trying to protect these robots, or the rover Curiosity, from our human germs of getting into that rover and then being sent to Mars. And unfortunately, what I found with my research is that we can't sterilize these rovers fully, and there's a certain percentage of microbes that will most likely make it to Mars and have been there for decades now with all the different rovers and other devices we have sent to Mars and beyond. So that's unfortunately kind of bad news for us astrobiologists, because that's the ultimate irony. We're hoping to find life on Mars, and we may have brought it there a long time ago ourselves. But fortunately, if we did bring anything, we always choose the locations of where we send these rovers very carefully. So they're usually sent to areas where the likelihood of some alien life being there isn't that high, so we're not actually going to contaminate those places. The places we really think life could be is probably underground, and I will tell you more about that shortly. And so as a little reward for my work there at NASA, I was able to put my signature into the Curiosity rover, which is now on Mars, so that was like a nice cherry on top of the cake for my work there. But unfortunately, for visa reasons, I had to go back to Europe. And I decided to continue with the theme of the life in extreme environments, or what are the extreme limits of life on Earth as we know it, which then can help us find life somewhere else. So for example, here on this picture in the middle, I'm in Greenland studying what can survive on what may appear as a bare glacier surface with no life on it. But actually what we found is glaciers are teeming with life. There's lots and lots of life there. And if you look at this picture, and hopefully you guys can see it on the slide over there, there's actually a lot of like brown patches all over this glacier. And it's not just dirt. Yes, in part it is dust that's blown onto the surface of glaciers, but actually it's mixed with a lot of microbes. And these microbes, not only do they survive on the surface of glaciers, but they actually really thrive there. They're able to produce a lot of organic matter through photosynthesis and other mechanisms. And this organic matter they produce, when the glacier melts, the water brings it all to surrounding ecosystems, and they're actually feeding huge amounts of other organisms through their activity on the surface of glaciers. So for decades, people thought they're barren, there's nothing happening on glacier surfaces, and actually it is a place filled with life. And that gives us astrobiologists hope that we could potentially find life somewhere on in moons like here on the picture. That's Europa, Jupiter's moon. It's covered in ice. We think that there's probably a subsurface ocean that exists under this icy surface. And so either in the ocean or potentially within the ice, we could find similar types of life forms. So that's the research I was focusing on, but actually finding out that these organisms are capable of producing so much organic matter inspired me for a project that's related to Mars. Because I realized if they can produce so much organic matter under such very poor conditions, could we use that, for example, to fertilize soils? And that's actually how I got involved with my first simulated mission to Mars. There was a competition, UK-wide, for the first British crew to go to simulated Mars. I'm not British, but again, I was trying to find some other way. So I was doing my PhD at a British university, and I applied anyway, hoping that they would accept me. And they really liked my research ideas and my experience, and so I was selected as part of the crew. And the research that I focused on, you can see it on the picture on the bottom right there, and the red outfit I'm wearing, that was actually mixing these extreme organisms from Greenland with simulated Martian soil to see whether they could fertilize it. And indeed, they were able to fertilize it to some degree. We were able to grow things using this type of soil, which gives us hope that not only we could use similar technologies in the future on Mars to start growing something for people there in the greenhouses, but actually even on Earth, unfortunately, with the climate changing, we may need to apply similar technologies in different parts of our planet to be able to grow food here too. So it's kind of multifunctional. And since this mission went so well, and by the way, on the picture in the middle, that's the Mars Desert Research Station in Utah. That's where I did my very first mission. Since the mission went so well, I actually got an offer to come back later as the commander of a crew, and that's on the picture in the top right. And while all this was happening, I kept on being a little bit concerned that back home in my home country of Slovakia, not much was happening in terms of the space sector. And I guess I felt bad that so many young people like me would have to go abroad to pursue their dreams, and that there just weren't so many options for them at home. And so that's why I decided after my PhD, if there's a time in my life to go back home and try and make some changes, hopefully for the better, it was then. So I came back home to Slovakia. I joined a group called the Slovak Organization of Space Activities. I actually became chair of that group within a few months. That was not the original plan. And we prepared the first Slovak satellite. That's on the picture on the right, and you can see it behind my head. It's actually very small. It's only 10 by 10 by 10 centimeters. It's a so-called cube satellite. And the purpose of this project was to prove that in Slovakia we have the potential to develop space technologies that actually work in space, and that also the government should invest more in the space sector because it can actually help us economically, but it also creates a lot of opportunities for researchers, for young people, and again, so that we don't have such a massive brain drain, which we have at home, which I think around the time it was about 30% of young people were leaving to go abroad to pursue career opportunities. And while this project went really well, the satellite flew in 2017. Thanks to this project, a number of new technologies were developed, which led to startup companies being created. And now we have over 50 companies in Slovakia that work on space technologies. And this project was one of the first that really started this whole trend. This project is also one of the reasons why our government finally decided to start cooperating with the European Space Agency. Since then, we became a cooperating member of ESA, and then a couple of years ago, we became an associate member of the European Space Agency. And so now, Slovakians actually do have a chance to become astronauts because of this collaboration. However, even that's not very straightforward because the European Space Agency usually only allows countries that invest a lot of money into its programs to be able to fly to space. So we're not quite there at that point in Slovakia, but so many young people can now take part in different types of educational and research programs of the European Space Agency. So many actually work directly for ESA in mission control operations and things like that. And it all basically started with a project of mostly young people from SOSA, the Slovak Organization for Space Activities. Sadly, all our efforts weren't just met with a positive feedback, let's call it that. There was a small group of older male professors that didn't like what I was doing. I can only hypothesize why they didn't like that. Maybe because I was a young woman, maybe because I was making a lot of changes in our country, changing the status quo. I don't know. And unfortunately, they tried to blackmail me out of becoming a professor at a university. They spread lies about me in the media that I never worked for NASA and various things like that. And then, turned ugly pretty quickly. And it was pretty scary for me because I didn't think I was doing anything bad to anyone, and I didn't understand why I deserved such treatment. And a couple of colleagues, they also were on the receiving end of these negative vibes and activities of this small group of people, to the point where a couple of them almost collapsed. And it was during this dark time that a friend of mine gave me some great advice that actually changed my life in some ways. He told me, don't worry about these people, just keep doing what you're doing, follow your dreams, and your further successes are what's going to prove them wrong. And so I let the actions and my accomplishments speak for themselves, and actually within a matter of days after that conversation, I got a notification that NASA selected me to go on a simulated mission to Hawaii. And I decided to take this opportunity to have a bit of change of environment from all the negativity back home. It was a collaboration between NASA and the University of Hawaii. And sadly, this mission didn't go according to plan, and I'm happy to tell you more about that another time. It's a long story. But the positive side of this experience was that the owner of the facility really liked my ideas, my work, and actually I got an offer to stay in Hawaii and become the director of this facility called High Seas. And I will tell you more about this facility shortly. But I do want to mention that even though I did end up staying in the US, and that was about 6.5 years ago, I still try and keep one foot in Slovakia because I find it so important to create opportunities not only for companies but especially for young people. So for example, I organize different types of competitions for Slovak organizations to take part in my missions. So in the picture on the left where the big Slovak flag is, that's a Slovakian rover that I took on a mission with me. And then currently I work with 2 Slovakian space companies that are represented here, Space Scavengers and Neutronics. And there are many other such activities that I try and do still back home, and I'll share a little bit about that later. So let's go to these simulated missions. What are they about and what are they for? The purpose of these missions is to recreate what it will likely be like on Mars and on the Moon during the first missions there when we send humans. So we will all probably live in these small domes. This is about 12 meters in diameter. 6 people should be living in that space, and I will try and show that on the other side too. But next to the white dome, that's the habitat, the living quarters, you can see a huge solar array that's to collect the energy that's basically running the entire facility. And then next to the dome, there's also this small rectangular building over here, and that's basically what's keeping us alive. All our life support systems are stored in that area. And you can see the whole environment looks very alien-like, Mars-like, and it's one of the reasons the facility was built where it is, and that's on a volcano in Hawaii at approximately 2,500 meters in elevation. So you can see there's no civilization, nothing really resembling Earth around us, but also the geology is very similar to what we know currently exists on Mars and on the Moon. So all the research we could do at this facility is directly relevant to what humans will one day probably do on the Moon and Mars. And so we're there trying to live and work as those first people that will likely go to Mars will have to function like. And that can be very tricky at times, but let me first tell you a little bit about the actual space inside. So you enter through an airlock, which is shown in this picture. And the airlock, you can see it a little bit more in this picture on the left. So it's this space where you can see like a green button. That button basically helps us change the environment from Earth-like, which is inside the facility, to something that's Mars-like, like the environment outside. And you basically have to first put on your spacesuit, which is in this room on the right. That's the rectangular area I was telling you where the life support systems are. So here we put on our spacesuits, we go through various protocols necessary to be able to exit the station, and then we go into the airlock where we go through this procedure where in a way the pressures and gases and things like that change, similar to how it would be one day on the Moon or Mars. That button goes from green, changes to red, and then we're able, we can't go back into the facility, but we're able to go outside to the Martian terrain. And I will tell you a little bit more about those expeditions into the terrain in a moment. And inside the facility, it looks like this. It might look spacious and nice in this picture, but in reality, again, it's only 12 meters. And while each of us has our own desk where we work, imagine, it's actually a very shared space with lots of noise. So for example, Imagine that you're working behind your desk on something very important, but right behind you, this is the treadmill, pointing out on both sides here. There's a treadmill, and someone has to be doing their daily exercise. So they might be running really loudly, maybe you smell their sweat, maybe they're listening to music that you don't like, and you just have to be able to continue working despite that. And then right next to that is the kitchen area, which is on the right of this picture. And again, there might be people cooking, eating, all while you're trying to focus on this work that you're in the middle of doing. So it can be a very challenging environment, and that's why we choose people that are very patient, that are adaptable, and that can communicate well during these missions. But the number one thing that's vital for the success of these missions is that the people are empathetic. And I will touch upon that a little bit more in a moment. And then up here where these blue doors are, that's where we have basically the only area with some privacy, which are our bedrooms. You can see me here for scale on the picture on the right. That's what the bedrooms look like. It's a very limited space. It can be a bit claustrophobic, but all of us need some privacy from time to time. Fortunately, also the bathrooms are where you have some privacy, but that's basically it. Apart from that, everywhere else on the station, everything can be seen and heard. There's also cameras that are following us the whole time. And so let me tell you a little bit more about what it is like to live on Mars. Some people might think it's something futuristic and fancy, but actually it can be very basic. And to explain that a little bit more, what do you think this is for? This red bucket. It's, as someone from a mission said, it kind of brings us back to maybe our primordial first humans who would just take a shower with some water they pour on themselves. I don't have a very good example here, but maybe something like this. So we don't actually use the entire bucket, but we use only a container that's about this big. We fill it up with water, and that's our shower. And we only get to shower about once within the 2 weeks that we're on a mission. So imagine again, once every 2 weeks, you only get about this much water to shower with. And so why? Why is it like that on Mars, that the water is so limited, or even on the moon? This is because resources are going to be very precious during these missions, true missions to the moon and Mars. We can't send a ginormous spaceship that's going to have water and food and all the other materials we need for like a 3-year mission. It's just going to be very hard. We're currently working on technologies that will allow us to potentially like suck water out of Martian soil or to melt ice that's on Mars, so we have some other sources of water. We can break down the water into oxygen and hydrogen for other resources, but we also have to go there with some amount in case those technologies fail. So we have to learn how to preserve water as much as possible, and that's why our showers are so limited. And washing dishes is actually kind of similarly not super hygienic procedure. That's what's on the picture on the left. You can see my colleague washing using 3 white buckets. The first bucket, where she is at actually, is where we would soak the dishes for some time, to kind of loosen up the dirt and the food that's on them. Then the second dish, or the bowl, is where we would add some detergent to scrub the dishes clean. And then the last bucket is where we would just kind of rinse the soap off and put them to dry. And we would only change these buckets, we would only change one of those buckets once a day. The rest continues to be recycled. And so it can be a bit tough. We would actually sometimes have to play a game to see if the loser would have to work with the so-called yuck bucket. That was the first bucket where things really got very yucky very quickly. And so why is this useful for us? So not only does it teach us to work with our resources better on Mars, but it's actually very important for us to value more what we have here on Earth. One of the things I always try to teach my crews on these missions is to appreciate what luxury we have on this planet, and how, unfortunately, we don't appreciate it as much as we should many times. And so, fortunately, most of my crew members, when they would go back to Earth after these missions, they really made sure not to just run the tap like crazy, to shower less perhaps, to limit their water usage. But the same goes with food usage, not to waste too much food, to be less consumeristic, and to really care for our planet more. So I had this secret goal of mine behind the kind of partial torture we had to go through, but it was really the first goal to help us be prepared for Mars. Food was also a bit of a challenge for us. This is what it looked like. So on the pictures on the right, I can see here, that's what our meat looks like. And I always joke that it's kind of like granules for dogs or dog food. And the material here, the dark brown stuff, that's beef, and the one below, that's chicken. And sadly, when you don't prepare it well, basically the color is the only difference between the two. So it can be pretty hard to eat that. And especially if you don't have good cooks on the crew, you're basically eating this mush that's in the picture in the middle. And now just imagine eating that for breakfast, lunch, and dinner every day for a several week or several month mission. So that's one thing we found out on these missions, is how important it is to have people that can actually cook well, because it had a massive effect on not on just how effective we were doing science and all that, but basically our happiness, our mood was very dependent on the food we were eating and the quality of it. And that's also why we would actually try and grow as much food as possible. So in the picture on the left is actually some of the other freeze-dried food, or astronaut-like food on the picture there on the left, sorry. So you can see some of it wasn't too bad, like the freeze-dried strawberries, that was basically our dessert. We always were looking forward to that. But then you only get like a box of those, and you have to survive sometimes for weeks with only one box of strawberries. And so you can imagine if the crew doesn't manage their resources well, the strawberries disappear within a day or two, and then no more strawberries for the rest of your mission. So it's also kind of about training the crews to have some self-control, manage their resources better, and then also to motivate them to grow some crops of their own. The whole time I mentioned we were being watched by cameras. These cameras are linked to a mission control we have near the facility. It's about an hour away. It's not quite NASA Houston, you might know from films, but it kind of looks like what you see on the picture on the right. There's me for scale. So there we have the cameras that are following the crew members along. We also have information about how much air is in the facility, how much water is left, how much power is left, because power comes through the solar panels. We store it in batteries, but when there's bad weather, we start to run out of this power pretty quickly, so we have to go into so-called low power mode to manage with the resources that we have left. And then the crucial difference between simulated lunar and Martian missions is actually the communication delay, which you can see in this picture in the top. With a simulated lunar mission, there's only about a couple-second time delay, which means you could essentially have a phone call with someone from the moon to Earth, and it'll be a bit choppy, like if you have bad signal somewhere, but you can essentially have a call if you need. However, with Mars, there's a 20-minute time delay imposed in each direction. That means, imagine if someone breaks their leg. It will take 20 minutes for your message to go to Earth to tell them person X broke their leg, and then another 20 minutes will pass before you receive any kind of response from them. So it would take at least 40 minutes to get some help from Earth. By that time, that crew member's situation may have deteriorated dramatically. So we teach the crews on simulated Mars to be as independent as possible, because help is very far away. And if any of you are familiar with the book or movie The Martian, you know that it would take many months or even years for someone to actually send some help to Mars. So it's all about teaching the crew members to be independent, self-reliant, but some actually like it because there's less interference from mission control. They can adjust their schedule as they need, whereas on the lunar missions, even though they have help nearby, quote unquote, they're being told what to do all the time and basically followed by mission control on a very regular basis, which also gives us a feeling of kind of being trapped in that environment. And related to that, this is what our schedule looks like. So with the lunar missions, our schedule can be broken down even to like 5-minute intervals, depending on the mission, because astronauts' time is very precious, costs a lot of money to send people to space, so we have to use their time to the maximum. So we will, for example, do some research. You can see on the picture on the left, a couple of my colleagues doing some geophysical research. We have to do exercises, depending on the mission, maybe half an hour every day to 2 hours, and that's because we're simulating what it will be like on the moon or Mars one day when our muscles and bones will change with a different gravity. So we have to exercise some more to help them feel somewhat like they're on Earth. These are some other exercises to give you as examples. For example, in the picture on the left, we had an acrobat on one of our crews, and she was teaching us to do a lot of work upside down, kind of simulate being in a different kind of gravity environment and having to function under these different conditions. We also had some prescribed group exercises, that's the picture on the right, that we had to do. Then I would give crew members training in geology and other things that were important for the mission, so they would be ready to explore the challenging terrain they were in. Each crew member had some kind of role or thing they were responsible for. So for example, here's a crew member in our engineering bay, so that's the place with the things that were keeping us alive, for example, the batteries, air supply and things like that. And here's actually working on some 3D printing project. And then we also had crew members working on different medical experiments. So for example, in the picture on the left, you can see a crew member is wearing a headset that's monitoring our brain activity. And as part of that particular research project, we were trying to see how less efficient we become the more we're tired. So basically, they were trying to get us really exhausted, and they were monitoring how quickly we stop being good at our work the more we're tired. And then on the picture on the right, you can see a colleague again is monitoring all our life support systems, making sure that we're in a good place to survive for the next few days. And then we also simulated doing different types of surgeries, again, to teach the crews to be more independent on Mars and to be able to take care of medical emergencies themselves if necessary. This is just simulated. My colleagues were just acting in that picture, so don't worry, they're not chopping anybody up there. And then we have to report about all our activities to mission control every day. So on the picture on the right, you can see me writing a report about the activities we did today, asking for permission for what we want to do the next day, asking for help if there's something mission control can do for us, and things like that. And that was probably the least favorite time of my crew members, because you spend hours behind a computer just writing about what you did the day and asking for permissions, and it's not the funnest task, which is why whenever I was the commander, I also made sure we had plenty of time to socialize as a crew. And that's what's on the picture on the left. You can see us watching a movie together. And I found that these times were so important for us to bond and become better team members. Because yes, you can put a group of people together, lock them up for some time, and just have some kind of leadership that's more like a dictatorship and tell them what to do and somehow try and survive as a group of professionals working together. However, if you can make it more of a family environment where people actually want to be together, where they're having a good time, they like each other, then they want to help each other out when something bad happens, then they will forgive each other if someone accidentally does something to upset somebody else. And that was always my goal, to make us go from a group of professionals to a family. And so, for example, I was teaching them some hula dancing, because I learned that when I lived in Hawaii. So just another example of a fun activity we did as a crew. We were also able to go out at night to do some astronomy work, though, of course, we're looking at the sky from a point of view of Earth, not Mars, but we were at least able to test some technologies in those conditions. And so now a little bit about the research that we do during these missions. I focused mostly on astrobiology, still my favorite science so far. You can see me on the picture there, tiny little figure above a huge cave. That's a lava cave, so again, that's me on the picture there. And we know that these types of caves exist on the Moon and Mars. They form during volcanic eruptions when you have a river of lava flowing down a mountain, and the top layer of the lava will eventually start to harden, and the hot stuff will continue flowing and it'll leave this kind of gap behind. And these tunnels can be kilometers long, and some of them are humongous, where you could actually even build a station inside these types of caves. And that's some of the research we were doing there. We would actually go, sometimes we'd have to crawl inside these caves to study them better. I would study the astrobiology. So for example, if you look at this picture on the left, you can see there's these interesting colors. Those are all microbes that can survive in these lava caves. And we think that something similar could exist in caves on Mars. We know that similar types of caves likely are on Mars still today. It's underground, so it's also likely that on Mars you would have a reservoir of water in this kind of environment, which would provide water to these microorganisms. The lava rock is rich in nutrients, so they have something to live off of. And so that's why we were studying these with NASA, to basically see if something potentially like that could exist on Mars today, or if we could at least find fossils of similar life forms on Mars. But we also try to study if we as humans could live there. So you can see some of these tunnels were pretty huge, where people could actually walk through them, and we could build small facilities there. And then we did various other research like geology, which is what my colleague is doing on the picture on the left. Then we would test different types of technologies, again, to prepare us to actually do these missions one day on Mars. So on the picture on the left, we're testing communications technologies for our spacesuits. Then there's a rover on the right, that's actually that Slovakian rover that I took on mission with me. Then on the picture on the left, a colleague of mine was testing whether we could use simulated lunar regoliths, so that's the soil on the moon, and also we could do it with Mars, and turn it into bricks. And then we could basically on the spot build things like even the stations for the humans on Mars using these bricks. And on the picture on the right, a colleague is actually using a geophysical instrument to find these lava tubes, these underground lava caves for future study. And then we also had a colleague on the picture on the right that was using satellite technologies to predict weather for us. We tested bigger rovers in collaboration with NASA and different organizations. And on the picture on the bottom left, they're again developing better spacesuit technologies for future use. And one of the probably most important things that we did on these missions was studying human factors. Because while we may have the best technologies to get us to Mars, if we can't have the crew work well together as a team, then those missions will fail. And so this is just an example of an interesting research project we had on our mission, where we were studying whether showing your emotions directly, or basically having people know exactly what you're thinking or feeling, is better than just kind of forcing you to communicate it yourself. So we're wearing these, what we called mood sweaters. That's what on the picture on the right is blue. And it's a sweater attached to a sensor in the palm of your hand. And it's meant to detect how you're feeling. If you're happy, sad, angry, content, all those sorts of things. And then it changes color depending on how you feel. So in the picture on the right, we're all standing on top of a tiny little towel. It's maybe a team exercise you might have come across. And you have to turn the towel while you're standing on it. And that's why we're doing kind of these acrobatic exercises there. We're really focused on the task. And all our sweaters are blue. Then we had to do, as a picture on the bottom left, we had to do a team exercise to help us bond. So we were asking each other, how you're doing, how many brothers and sisters do you have cats, dogs, and all that. And you can see all our sweaters are purple, because we were in a happy, content kind of place. And in the picture on the top left, we were asked to do a task that not every crew member enjoyed doing, and I won't reveal what all the colors mean, but maybe you can figure it out yourself. Let's just say some crew members enjoyed the task less than others. And it kind of showed us that perhaps it's best not to always show how you're feeling, and have it literally like written on your forehead, because sometimes you don't want the other people to know that you're annoyed or angry or whatever. So that was like an interesting exercise we did, and it really helped us communicate better so that we weren't forced to wear these sweaters. And another kind of, maybe I'll share a couple of personal experiences about why empathy and good relationships in the crew were very important. So in the picture on the right is actually from a time, by the way, we only have 2 windows on the entire station. That was one of them. And each crew member would spend quite some time every single day looking at the window. It was essentially the only way to escape reality. And I was escaping reality because I had found out that a family member passed away while I was on mission. And I think it was a Mars mission, so I couldn't just pick up the phone and call my family. I couldn't go to the funeral. I was responsible for a crew as the commander. So it was a very hard time, and I wasn't sure how I was going to manage. But I decided to tell my crew about it. I was honest. I told them that right now I'm not really in a position to be a leader, so I delegated my work to someone else that I thought was capable of it. And I just took some time for myself to grieve and to go through this hard time. And part of it was escaping reality, looking at Earth, and or thinking about Earth anyway. And that really showed me how important it is for us to have these family relationships, because the crew helped me get through those tough times. They, took care of some of the work that I had to do so that I could focus on me getting emotionally better. And then in the picture on the left is a kind of different situation. It was my actually very last mission that I was the commander of in Hawaii. And the crew was able to surprise me, which I must say is quite an achievement, because in that small facility to surprise anyone with anything, it's not an easy thing to accomplish. But they were able to bake a pineapple cake. That's what they're holding, or I'm holding in the picture over there. Wrote me a nice card, and it was basically a thank you for me for all the work that I did at high seas as a little farewell. And again, it just kind of showed me the importance of having these family bonds. And thanks to these types of groups that I worked with and the fact that we prioritized empathy and communication, I now have space families all around the world, and all of my missions were successful. Never did we have any big arguments or problems that we had to deal with, and that's what I keep on telling people, that if we want successful missions in the future to Mars, we'll have to do similar types of work together. And some of the things that I also took away from these missions is how important diversity is. The more diverse we had a crew, the more we bonded. And that was because we were always learning something from each other. But also when something bad happened or we had a problem, each of us had a little bit of a different perspective on how to solve the problem. And I mean diversity not only in terms of what nationality or gender the people were, but also if they were, for example, teachers versus the typical scientists and engineers that we had on crews. We had journalists, artists as part of teams, and that really helped diversify things. And on the picture on the right, we also had a mission with a para-astronaut, so someone that had a physical disability. A lady in the picture in the middle, you can see she's missing part of a leg. And so we're trying to make these space missions also more accessible for people who might be very talented in some way, but a physical disability might be preventing them from doing a lot of work that other people might do in the space sector. But also, we have to be prepared for something truly bad to happen in the future on, say, Mars. Someone might actually break a leg or hurt themselves, and we'll have to be able to function under those conditions as well. And then these are just a couple of other examples of we had crews that were all female, or for example, where I was the only woman on the team, the rest were males. And then we would also learn from each other using different types of cultural experiences. So for example, in the picture on the top left, we were celebrating Thanksgiving. We didn't have a turkey on mission, as you can imagine, so our crew members baked bread in the shape of a turkey, and that's how we approximated that. And also we created other foods that were similar to what Americans have for Thanksgiving. We celebrated St. Patrick's Day, that's the picture on the top right, Valentine's Day, bottom left picture, and Christmases during missions, another great way for the crews to bond. And then, for me personally, it's always been very important to do a lot of educational and outreach activities during essentially all of the work I've ever done. So not only would I have journalists on crews that would film documentaries, for example, Space Drop is kind of like a fun version of a documentary about what it's like to be on a lunar mission, but I would also organize different types of competitions for young people in Slovakia, but also other places where they could invent an experiment, and the winning experiment I would take with me on mission. And so an example of that is this picture on the right. I'm holding this brown liquid, and that's dissolved hair. And it's an experiment that Slovakian high school students came up with as part of one of these competitions. And the idea is that, you know, our hair grows and then we cut it off, and what a waste during like a 3-year Mars mission to keep on just chopping off our hair and throwing it away. Why not use it for something useful? For example, we could dissolve it and use it as fertilizer. And indeed, we tried that, and this fertilizer was more efficient than some of the other industrial fertilizers we had on mission, and we were able to grow spinach and various other things using human hair. And that was a brilliant experiment designed by high school students that even Nat Geo filmed something about that, and other TV organizations. So to wrap up maybe this chapter of my life, before I tell you about what I'm doing now, are we ready for Mars? On one hand, we're making good progress with these simulated missions and other technologies we're developing. And when people ask me, when do I think we'll be able to go to Mars, I say, approximately 15 years from now. And that's if we want a safe mission that will go to Mars and back, bring back all the humans there that go on mission safely back to Earth with no injuries or major problems, because we still have so much more research to do. And while maybe some companies might build the technologies that can take us to Mars, if we don't prepare the humans properly and take care of their mental and physical health, those missions will not be successful. But also for me personally, it's important that these missions are not about just taking people to Mars, but also to have a good impact for what we do on Earth. And that's why a lot of the sustainability research I mentioned, of like making sure the water is rationed better, the food experiments where we could use extremophiles or extreme organisms from Earth to fertilize soils on Mars, we can also apply that to our work on Earth. And so a lot of what we do in the space sector is kind of has a double purpose and has been helping us in different ways in medicine, in industries, and so on Earth. So what am I doing these days? After leaving high seas, I decided to start a nonprofit in the US, and I have a similar kind of nonprofit organization in Slovakia, where I'm running a project called Astro 7 Summits. And before I tell you more about it, let me just explain a little bit why I went down this path. Unfortunately, during my time as a researcher in different types of groups all around the world, as a woman in science, or just a young woman many times, I unfortunately faced a lot of discrimination, harassment. I told you about the blackmail that I faced earlier. And it's been too many toxic work environments where I was severely underpaid compared to my male colleagues and things like that that were just really draining me over time. And I decided that instead of having to endure that time after time, let me just set up something of my own and run things my way and as ethical and fair way as I can. And that's basically how the project Astro 7 Summits came around. I've always wanted to climb the 7 summits, that's the tallest mountain on each continent, but I want to continue doing my astrobiology research, so I collect samples for NASA and other research institutions around the world while trying to study what are the limits of life on Earth. I also do various educational and outreach projects during each expedition, including filming documentaries. So this is just a brief overview of this project. Here I am on Kilimanjaro doing some research of the tallest mountain in Africa. Here is a map of the other mountains we're planning on going on. So we already have the expedition to the tallest mountain in South America under our belt, that's Aconcagua. Tallest mountain in North America, Denali, that was earlier this year. And in January, I'm planning on going to Antarctica, if all goes well, for my 4th expedition. That's me on Aconcagua, and just an example of some of the research we do in the extreme environments of these mountains, again, continuing with NASA-related research and similar other research programs. Then we test different technologies. For example, on this picture, I'm testing a satellite device to see if it can help us communicate, even at the high altitudes of mountains like Kilimanjaro. But also it alerts people of where we are in case something bad happens. It tracks exactly where we go, which you can see on this image on the right. And we can share data with our family, friends, but also our collaborators if needed. Then I bring educational projects with me, and that's this little flower-looking device that you can see in the picture there. That's an experiment for young people about middle school age, so say between 10 and 15 years old approximately. And they can use this device anywhere around the world to take the same measurements that I take of humidity and other values during my expeditions. That way, it's a kind of citizen science project where anyone around the world can contribute to my research and be directly part of it. And it has opened doors for a lot of young people to get involved in research, but also, for example, when they're applying for scholarships, they have this other opportunity to add to their CV and help them in tough competition. And then I also study climate change, and as a very brief example here, you can see me and my team on the summit of Kilimanjaro, and the ice is very far away from us on this image. But if you compare it to the images on the right, that's my father on Kilimanjaro in 1995, you can see the glaciers are right there near them on the summit. And this is just how dramatically the glaciers are changing all around the world. In approximately 10 years, there will likely be no glaciers on Kilimanjaro or any other mountains in Africa. And this is not just Africa, this is happening everywhere around the world. And this is another thing I'm trying to alert people to as part of this project. And then I go to schools and I talk to audiences like yourselves about the work that I do. So here's some examples of some of the outreach presentations that I give and interactions I have with young people around the world, trying to motivate them to also follow their dreams despite obstacles. Then we film documentaries. For example, Hakuna Matata Kilimanjaro was our very first documentary as part of this project. It has premiered on 4 different continents, and it will be in Prague in a few weeks, actually. So if you're interested, it'll be part of the EcoTop Film Festival. And what I do nowadays through nonprofits wouldn't be possible without the help of many sponsors and grants and partners. So I'm very grateful to everyone who's making this happen. And if you would like to help in some way or simply just interested, I have the book about my life with me here. It's in Slovak, so I know most of you probably won't be able to read it. But I also have these space patches. They're designed by a NASA patch designer, or designer that did patches for NASA. And he kindly designed these patches to support my project. So the patch in the top of the slide and also on my jacket, that represents the entire project. And he kindly represented me as a future Slovakian astronaut on the moon. and the colors of Slovakia here on the patch. And on the map in the middle, he showed in red dots the different mountains that I'm planning on climbing as part of this project. And then there's like a little hidden story in the patches as well, because the next 2 patches you can see on this picture, there's actually 5 in total. I have 4 more you can see here, or they're displayed behind this screen as well. They represent each of the different expeditions I'll be doing. And on these patches, you can see that I'm changing. So I'm going from a simulated astronaut in the blue suit, and slowly that astronaut starts to resemble the one on the main patch. And that's to say that with each expedition, I'm acquiring new skills that will help me in a future astronaut selection, hopefully, to actually become an astronaut one day. And then each patch also has the colors of the country where the expedition took place. So for example, that was Tanzania, Argentina there, the sky, the way we saw it during our expeditions, and other nice little details like that. So if you would like to look at those or potentially buy them to support my project, I'll be behind the screen after I finish talking. So feel free to come talk to me if you have any questions or you want to look at these things. And yeah, thank you very much for your time. Thank you very much.
Thank you very much.
Oh.
Can we?
There we go.
Thank you very much, Michaela. This was absolutely mind-blowing. Please let me know where do you keep your time machine, and so that I can use it too.
People do ask me many times, like, how do I fit it all in? And I'm like, I make it happen.
So yes, unfortunately we cannot do Q&As here now because we have to prepare this screen for Quaiola's installation. But please catch Michaela from the other side of the screen where you can find her there, and her books too, and the patches. So yeah, I invite you to do that. And I would just like to close down these amazing 2 days. I can't believe it's the end. Thank you so much for being here. It's been really amazing. Thank you to all of the speakers. I really think this was a very special case where, like, I feel everybody put so much heart and energy into their presentations and into all the discussions. Thank you to our moderators, Pavlina and Bartosz. That was also like incredibly inspiring to have you kind of dynamize what was happening on the stage. And last but not least, I would like to thank from the depth of my heart to the whole organizational team of Signal Festival, to Martin, who in the first place asked me to do all of this, to Michaela, who managed the whole project, to Itka, who helped us to communicate, and everybody else who contributed. Thank you so much, and I hope that we can repeat this next year. So enjoy the rest of Signal Festival. Make sure you see all the installations, and hopefully see you around. Thank you.